So the last page of notes here, it says infinite limits at infinity. So this is combining the two things. So in the previous section, we had the y values approached infinity. In this section, we've had the x values approach the infinity. Well, now we're going to be looking at the combination of the two. Both x and y values both approach infinity or negative infinity. So for instance, it wants us to look at the function x cubed. Well, if you remember, what does the graph of x cubed look like? Again, feel free to use Desmos if you want. The graph of x cubed looks something like this. I always call it an S curve, although it's really not an S at all. But that's the graph of what x cubed looks like. And if you notice, as you go to the right, it approaches infinity, and as you go to the left, it approaches negative infinity. How can we prove that? Well, simply just do your table here. Going to the right, I do a 1, a 10, and 100. Look, I'm looking for you to put at least 3 values in. Plug that into your calculator, your table feature of your calculator. Likewise, to go to negative infinity, I could do something like -1, -10, -100. And again, I'm looking as I go to the left. The first one I'm looking as I go to the right. Plug these values into your calculator, and you will see, once you plug them in, what's happening. As you go to the right, you should approach the number infinity, which you would. You'd have 1, then you would have 1 with a bunch of zeros, and then you'd have 1 with even more zeros, okay? And these numbers, these table numbers, those aren't the exact numbers, but fill in that table for me. You're going to see it goes to infinity as we go in this direction to the right, and as we go to the left, it would go to negative infinity, okay? The sign does matter. You got to be careful with those right there. So that's an infinite limit at infinity, right? So we're looking at the limit as x goes to infinity, and we got an infinite answer there. Again, remember, that means the limit does not exist. However, we can still put infinity and negative infinity to discuss the end behavior. So how about example 8 here? It says the limit as x approaches infinity of 2x squared minus 4x all over all over x plus 1. The first thing I would notice is if I plugged in infinity, I get an infinity over infinity, which is that indeterminate form, means we need to do more work. The next thing that I would notice is this is top heavy. And because it's top heavy, that means it either approaches infinity or negative infinity. So what's the easiest way to figure this out? The easiest way to figure it out is by looking at just your leading terms. So this is the same thing as the limit as x approaches infinity of 2x squared all over x. Well, that simplifies to just 2x, right? So this is the same thing as the limit as x approaches infinity of 2x, and now let's think about it. I'm plugging in positive numbers, so the overall positive thing would approach positive infinity. So the answer would be positive infinity. Let's look at the next one, though. It's the exact same function, 2x squared minus 4x all over x plus 1, but now we're looking at it as x approaches negative infinity. Again, I know that this would be infinity over infinity, which is indeterminate form. I know that this is top heavy. Top heavy tells me the answer is going to be infinity or negative infinity. The only way that I'm going to know is if I investigate more. So how do I investigate more? Just look at the ratio of those leading terms. So this is the same thing as the limit as x approaches negative infinity of 2x squared over x, just like the previous problem, simplified to 2x, right? So this is the limit as x approaches negative infinity of just 2x. Now let's think about it. Now I'm plugging in negative numbers, so think about plugging in negative numbers here. This thing would approach negative infinity. Okay, so again, top heavy tells us it's either going to positive infinity or negative infinity. How can we do it? Just look at your ratio of your leading terms. Once you look at the ratio of your leading terms, you can figure it out from there. How do they do it in the book? In the book, they do it a little bit different than that. In the book, what they do is long division. And they sit there and they do long division of the function and can figure out what it is. They figure out that there's something called a slant asymptote. You probably did this, or an oblique asymptote's another way of them calling it. Okay. You probably did this in your college algebra course. I don't care about the slant asymptote or oblique asymptote. That means nothing to me in this case. What I truly care about is that end behavior. I care about the answer infinity or negative infinity. And to find the answer for infinity or negative infinity, just look at the ratio of those leading terms. So it's a lot easier than what's shown in the book for you.